Remember to share this time. That makes a difference. Can't make a video unless you can see what I'm doing. All right. Here we are. What I've got open, yeah, is just my kind of my part assembly. So what we should have at this point is obviously my solid. Then I brought in a part derived in that solid as surfaces, got that. And the other thing I can open here is we should have we exported components, or we made components from that little part assembly that I have there, and it created this assembly. Oh, let me go back one. It created this assembly. I have an assembly file now in my assemblies folder, which pretty much, let's see here. Yeah, go ahead and update it. Which probably pretty much looks, so it's a .iam file. So when we exported those components, it created all those individual parts plus this assembly, which is going to become my master assembly for the housing, essentially. So now I have, if you remember right, when we created this assembly, or we exported those components, it asked if we were creating a new assembly or selecting a target assembly. So now that I've created an assembly, when I create the additional housing parts here, I will be able to select this as the target assembly to send those parts to. And so yeah. And so this will become kind of the master housing assembly. And then from here, because it created the assembly and the parts, now you can individualize these and open these up, right? And I think maybe at the end of the video, did I have I probably defined an A side, which is the outside of my housing, and I just checked the flat pattern. I think we did this together, right? I just opened up my flat pattern as an individual part. Yours will look different than mine because I've made a few adjustments, but what you kind of need to have is have these been created. So I have these individual parts from this assembly. This one here too. There it is. Because I gave them a new name as I was exporting those components. So really, this is where you got to be in order to be kind of caught up to me. And I had this part too. Of course, mine look a little bit different because I'm going to add a couple little things to it. That's a little front flap on the inlet chute. I've made a slight adjustment, but I'll walk you through what we did there. And so essentially, from this created an assembly and three other parts. And we can throw other things into it. But now I'm back to this part assembly. So you got to kind of keep track of this, right? You got to sometimes they look very similar. And so one thing I'll note here is I like to keep my derived part on in this little part assembly because it just is a visual cue that especially when I'm perusing through and trying to find a part just based off numbers, like what it is, maybe my visual will help me. This will help me cue in that, oh, I've got a derived part under here. And so I save my parts like this with the surfaces on, because here's just what I want to show you really quick is if, when you're manipulating, and I turn them off when I'm doing stuff all the time, right? I'm continually, if I need to get to a sketch area that I want, sometimes I have to turn off these surfaces and not work through them. They get a little bit of annoying. So I'm commonly turning these off. But then just remember whatever state you're in like this, when you hit save, if I hit save on this and then I'm done working with it and I close it, if I was just perusing through, and what I mean by this, I open a lot of my files from Inventor, use this open just like we always do. Um, Sometimes the state that I save it in really helps me identify it from this little preview window that I get. So I use this to my advantage all the time. Like if I was looking for that part and I didn't know where, see, I'm looking for these little previews as they show up. I click through these things sometimes just to know which one I want to open up. And this one wouldn't necessarily catch my eye in this state. It looks like an assembly, or it's in a part folder, but it kind of views as the last state it was saved in. And so this becomes kind of critical to me, especially when I save stuff and I'm working within a vault or a server or a library type system. I definitely want to be aware of like the state that I'm in when I save, and if that's easily identifiable in a mix of parts, or if it's hard to find, like a needle in a haystack. And so this matters to me. So if I would come through and I wouldn't know if this is it, and then I open it and it looks like this when I open it. The problem with that is it also looks just like the assembly that was created from it, like this. Even though they are in a different folder, it just gets confusing that this one looks identical to this one. But the reality is this one is that underlying where everything was exported from. And so to me, strategically use kind of displays settings, how I want them to look. This would be my visual cue that I've got a base solid under this. This is probably where I exported sheet metal parts from. And so you can use your, yeah, just be aware of like what state your model's in when you save them and you close them out. Sometimes I can help you identify them rather than looking for parts that look exactly the same. Yeah, go ahead. I can. Let me stop sharing. There it is. So that's one little note just to know. So I like to save mine like this, so it's in my part folder when I'm perusing through visual images of it. Maybe it will jump out to me a little bit more because this is the one that really I come back to control any changes on any of these parts that were exported from it. I try to hesitate and not change from on the individual part. It's not that I won't do it, but occasionally I will. But when you make a change on a part like this, it only really lives here in the part. It doesn't communicate back to where it came from. So if I want to make changes to these parts, what I just need to do is go back to the parts where they were exported from and make my changes there, and then they will then accept those changes automatically. So we're going to do a little bit of that right now. So I just have these open. Oh yeah. Well, that's kind of I mean, it's like one of my videos yesterday. It goes on for a little while, but what it was is I came into here. I mean, yeah, it takes you just a minute, but you come into here, and then on the sheet metal tab, there's a make components command here. And when you select make components, it's going to preload a target assembly name. Generally, it's going to pick the same name as your part file name to name it. In this case, I didn't want it to name it that. I actually just wanted to pick a new name. So and really what you're trying to do is just you try to pick the location of where you're going to save this is what it's going to do is create an assembly, and it's going to create all these parts that you want to. Um, and so it's gonna create a bunch of new files. And so you got to pick where those go, and the first thing you pick is where the target assembly is, right? So um, this is so usually I come over here and I'm like, well, let me make sure my target assembly is where I want it because it's going to make an assembly for me. And so this is what will always come up. Do you want to create a new target assembly? Or so select no to select an existing target assembly. I already have one. So if I was making new parts from this, I could send it to that target assembly. Originally, when I don't have one, I chose to make a new one. So I was like saying yes. And then it's going to give you, access to what folder, where do you want this assembly to go? And I wanted it to go in my assemblies folder. So then I named it and so I chose this folder, and then the name that I gave it was just a little bit different. It still follows up my little ISU naming format, ISU-MR-SC, but I just started with 100 in my assembly folder. Just because I didn't want, I mean, it will let you you can name assemblies the same as the parts. It gets a little confusing. I kind of try to avoid it unless I have a really good reason of why I want those two to be the same. I mean, in some cases it makes sense because I've got that kind of part assembly that I'm exporting from, and I've got that new assembly, the real assembly, that's going to have the same name. Likely they're in a different folder. So you can, I mean, it's not the, I mean, you can, yeah, you can let it name the same as the part name. It'll accept that because it's a .iam file. So I would guess that a lot of people do that, like leave them the same. I just chose to rename my assembly, and the reason why is because I was going to like I decided my assemblies were going to start within the 100 kind of prefix. So my first assembly is SC 100. My second one will be SC 101 and 102. And so I'll kind of have a structure to build, some consecutive assembly numbers, kind of like I have in the parts number. I started with, SC 001, then I went to 2, 3, 4. So I've really got 99 parts until I hit my assembly, if that makes sense. Yeah. It was just kind of a numbering system I just developed on the fly, actually. So, and it's just a way to keep things separate. Because eventually what happens is your numbers kind of become obsolete to you. As long as you can identify what they are and there is a numbering system that kind of makes sense, it doesn't even matter if parts are made in consecutive numbering systems at all. As long as they have a unique number, that's it. And so I tend to rely less on what that number is, even in work environments where they're supplying me the if I'm having to, yeah, if they're supplying me the part numbers, because some companies will embed like a numbering system that pops up when you do this, and they will like, and it's just been developed by somebody in template world has developed a way to auto populate the way they want their parts numbered. And so numbers just become numbers to me. They're just unique. They keep files separate from being, overwritten of each other. That's really the goal of it. Identifying stuff from a number is actually really hard for me, especially in a really complicated assembly. So my previews, I'm a visual learner, obviously, and so not that everybody is, but I use my little preview window pretty heavily when I'm looking through parts that have like pretty much similar numbers. I'm like, I don't know what that number is. If I change my assembly numbering to a dash, to start with 100, at least then I'm like, oh, okay, now I know an assembly would start with a 1. And so that would be a cue. So there are some numbering strategies I think I could use to look from a list of numbers and be like, well, 100s are part or assemblies. Yeah. I just say this because it's all about organization. If you learn, I mean, if you've learned anything here, you get a lot of parts to manage. It's organization, it's file structure management. And it's, yeah, it's less about, yeah, but it's just a big part of your life in drafting. You got a lot of files to manage. So structure matters a little bit. So this was what I chose. I chose like a new assembly and gave it a name and everything. And then I said, okay, I'm going to cancel this because I don't want to do this. But it will go to another menu. Um, it will pop up another menu that will then have, well, then it goes back to this actually, and it's and now it'll be like which well, let me just kind of do this real quick. So I guess I'm gonna explain it again, but here we go. This would be my target assembly. Oh, I don't want to replace this, so I really can't do this without messing up all my stuff. I would just say go back, go back to the video and watch what I do. But I give it a new name that populates here. That's going to be the destination. Then you've got to select your parts to show up on the list here. So then you're choosing what are you like exporting or what are you making that are going to be individual components. They show up on this list, and then when you hit next, I think I can do this and it will go to this secondary dialog box where now you have to go in here and choose where they're going to go, choose the source path, which is going to be my parts folder for me. And I would choose my source path for all of those parts that I've created, and then I give them a unique name here. And I would just follow my naming system. So what I did is I kind of opened up, just my folder where I'm keeping all this stuff. And I can take a look pretty easily at my parts, and I could recognize that I had some parts in there, and then I started naming mine like 5, 6, and 7. Those were my 3 new part names. It's just because when I open up this, I can see them pretty easily. Like, what's my next one going to be? Oh, it's going to be 8, 9, 10 when I start making parts. So I'm just kind of aware of what I am. It doesn't really matter if I miss a number and I skip it or whatever, it doesn't really matter. They don't have to be perfectly consecutive numbers. I just want to pick a unique number in my parts folder that isn't, and I'll try to stay consecutive unless I miss something. But so I have like, yeah. So I've done that. I've selected those. I've given them these names. So I populated those names here. And then when I hit OK, it actually will jump you to that new assembly that it creates. And which is this for me is this one right here. So I'll cancel that real quick. Then once you click OK on that, after you've like set your target assembly for your assembly or given that a name, and then you've gone and chosen which parts they are and given those names and chosen where they're going to go. Then when you hit OK, it just like sends you to that assembly, which to me it would send me right to here to my .iam assembly that it created for me. And then from here, I can open up individual parts. It's kind of like ground and rooting them in a way, right? Like I don't have to do any constraints in this assembly because they've been built from that. They've been built from that other part file, and so they already know. They will go to their home essentially. Yeah. So I didn't even have to constrain these in the assembly. That's kind of the nice thing about this is that you're just, there's no constraints. It can be a problem if you want to get to an assembly and have some animation done on the assembly. Well, then we've got to maybe bring it in differently because of the constraint issue. And sometimes you need to relieve constraints in order to make some animations. So it doesn't work for everything. Like these parts are not going to move in an animation necessarily. So this would be a great reason to just, make components, have them pretty much ground and root themselves in the assembly. Yeah. Okay. And then I had all the three of these parts that are now individualized with their unique names that live in my part folder, and there they are. And now to change anything with this, I actually don't change it here. I come back to here. So let's do some changes. So you've got some, so yours is probably looks a little, well, it might look a little different because I think we ended up like thickening some of that and making these parts. You can go ahead and delete those. If you have those on your, in this kind of part assembly where I derived in the solid. And we were playing, I think I was playing around with some of those. I'm going to go ahead and delete those out, and I'll make a unique little part assembly for each material size that I have. I think that will be good. I think it's a good clear-cut way of doing this. And so all I'm going to mess with here is just the 12 gauge parts. So if you have those other ones, you can delete them off. Get back to your 12 gauge parts, and I'll show you what we did here. So I'm thinking, how am I gonna? Okay. So this one's pretty easy to fix for the main housing. Will be a pretty easy one to fix. What we have going on there is I didn't like that there wasn't a cut separation between this little flange here and then what will remain straight here. So you got to think origami a little bit. Like that is going to be the same when that unfolds. It's going to be the same flat material. But then in order to bend it, we need to cut a relief there to allow those bends to happen. And the person that has to bend this, they have to not bend that, but bend this. And so you have to position parts in the equipment that they have to bend strategically, which is very doable. And so, but we need to have, and so on my flat pattern, probably the way you guys have it, there's just no seam there. And so this is a pretty simple fix. It's just going into your sheet metal defaults. And I'm in my little part assembly. And I would go to my sheet metal defaults, which is where we define 12 gauge. And I'm going to go in here and do an edit. And you probably will be on the sheet here where we set stainless steel and we set the thickness. We never change anything else here. It just shows that we're going to use some default K factor in bending. And then if it miters, rips, seams, gaps, it's going to do it by the thickness, which is 0.1094. But oh yeah, let me do this. Thank you, thank you, thank you. Back into the screen. Yeah, what I've done is I've just gone into my sheet metal defaults, and I'm going to just do a quick modification here on my 12 gauge rule here. Because yes, I've got the sheet size selected, but on bend here, you can see here, this is your little right now you guys have something different right here. I can't remember what it is. Maybe it says thickness. I think it says thickness right here. So what it's showing is got a few variables. What I was looking to shorten up, because the default was straight, and this was, I think this was set at a thickness, so it was a really big, which might be all right. That's just what default is. I'm going to tighten that up a little bit. I'm just going to give it 30 thousandths of clearance here. I don't want so much, but I do want to create a cut here so I set my relief width to 30 thousandths, 0.03. I'm trying to keep I'm trying to not to add too many different tolerances. I've used 30 thousandths pretty strategically through this, and I kept with that. I think it's a good number here too. So it's just 30 thousandths. I didn't change the relief depth, but we could if we don't like how deep this is cutting to allow these bends. This is just kind of a relief depth that's being automatically cut. It's half of a metal. It's about what I'm at here, but it's half a metal thickness essentially. Thickness times 5.5. And then I don't think I'm going to worry about the minimum remnant here, but it's actually 2 times the thickness. So the only thing I changed was 30 thousandths for the relief width. And I didn't change anything on the corner either, but if we ever have maybe I may have changed this. You might be on, is it trim to bend? Yeah, trim to bend maybe is what is default. I'm going to go ahead and say I want that to tear as well. So this will remove quite a bit of material in a sheet metal part, which is allowing for the bend. It's almost allowing enough material removed for the whole radius of the bend. I think this gets way more critical on when I get heavier, maybe 10 gauge, which is about 1/8 of an inch thick, maybe even like 3/16 inch plate. I might want a little more relief here. For 12 gauge and under, I feel like I can go to that tear and not have it move additional material. So if I go tear, I don't get a lot of like relief cut in those corners. And you don't need a lot of relief cut on thinner sheet metal. 12 gauge is kind of in that like, do I or don't I? And anything less than 12 gauge, I would definitely not need any kind of relief cut because it's thin material. It's hard to weld corners anyway. And if I remove material, it's just holes that I have to fill. And so I think I just set that to tear. I set that to 30 thousandths and I just said save and close. And I just said accept. I don't know what it's going to blow up. This bend here. Oh, I don't know. I wasn't expecting it to bend or blow up on me here. So I'm not sure which one. Oh, it blew up this one maybe. But I'm gonna show you how to change these ones too. So that's good. That's good. Yeah. I wouldn't what it should have done though, it should if you come and look at this flange, if you make that change, it should look like this now. You should see that 30 thousandths show up right here in this relief. Oh yeah, yeah. So now, okay, good. So now, good. So now go back to your flange. Good. I'm glad I couldn't remember all my steps I went to. Come back into here, and I don't know if I had to change anything though. Yeah, did I have you? Oh, I had you on tear here, right? Yes, tear. Switch this back to sheet metal defaults now, or this that kind of looks like your sheet metal defaults like emblem. Yes. Let it accept that now. Because what we've done is we've done that. We've done a little bit of programming in that sheet metal default. Rather than do a spot change here individually, I'm kind of trying to drive all my bends to do that. So yeah, definitely move that back. Say okay, accept that. If it keeps blowing up that one bend on me, that's okay. So now do you have this little gap here? Okay, good. That's what we want. Yeah, that's just going to be like as I would edit that flange right here, edit a flange. So I'm going to pick that. That's the first bend we did, these two flanges. So if I go to edit that feature, I know these bend dialog boxes are huge for sure, but it's the difference of changing from tear like I originally had you guys do to changing to running with the sheet metal defaults that I've now preloaded to be 30 thousandths in that particular, in that particular orientation of the part or that particular feature of any part. And then I'm going to say okay. And then you may get something to blow up. Just say accept it and we'll work that out if something does blow up. But what I'm looking for is to create is just a little separation between those two. And that bend width, the other relief that's being cut is from here to here. And I could decide later that I don't want this either, but I'm going to leave it in right now. So I'm letting the default like that. It was the B variable in that little selection is how much this is cutting into me. So, and that I did both those flanges on the same command, so it should have done both sides. The other thing I'm going to do is I'm going to fix that on the other flange too, even though it isn't impacted by that necessarily, this outer flange. I'm just going to kind of think consistently. So if I made that change to this flange, I'm going to make that change to this flange as well. So I'm going to edit its feature and I'm just going to run it by default settings here too, which won't impact that at all. It doesn't have any of those features to relief cut for, but I'm just going to keep, keep things organized. I do that a lot. Like if I make a change, or I find an error with how I drove one of my flanges, and I have a bunch of flanges on a part, I may need to go through and follow those changes through, try to keep them uniform. Because that gets hard to determine too. If you've done different things on your flanges, generally you'll find that once you get a flange setting that is predictable by your equipment, there's going to be very few changes you'll make to that. It'll be more of just making sure those are always the same because they've been vetted by the company to bend on their equipment correctly. And so it's not like are always like picking and choosing necessarily, like we're doing a little bit ourselves here. But once I find something that works for me, I'll be like, oh, I'm going to apply that to my other flanges as well. So that corrects that issue. And when you do changes like this, I'm going to keep making some changes before I go check my other assembly. But when I'll just bounce over there really quick. Anytime you're making changes to that thing, you're going to get these lightning bolts going off like they need to accept an update. And we'll just update them and those will, the things that I've done on that other part are gonna just downstream feed this part as well. So if I'm making real heavy and extensive amount of changes, I sometimes go back and forth between that part a couple times and update it so I don't crash it. I don't know if you do like a major overhaul, sometimes it's helpful to do that in littler chunks and keep updating that other file. Um, Nothing we're doing here is that major, but The other thing I did is I added a 3/4 inch flange um, to this little raw edge here. I did it very last, but you could do it now. And so what I've done is I'll come in and edit this feature. But your part should not have a flange there. It should just end as a raw edge. I wanted to bend it because I want it to kind of act as a seal on the lid as well here. So I don't just want that raw edge flapping there on the inlet. So I'm going to stiffen that up by adding a 3/4 inch flange. And I think I just had to pick this instead of this direction. I want it to drop and be flush with my finished flanges here because my lid's going to span across there. And I don't want this to have an interference or higher than the top surface of this flange. So I think the only thing I had to do was, yeah, I picked 0.75 as my length and I chose to drive this down like that. And so it's 0.75 kind of in it looks like an ID dimension, but I kind of view that as an individual flange as kind of the outside di dimension of the flange. And I would consider this face to this edge to be the inside dimension of the flange, kind of. So if I speak like that, it'll confuse you a little bit, but it's the way I visualize flanges and sheet metal. But that's what I want to add there. I'm just going to keep the same default there selected. I didn't change anything else, so I'm just going to say okay. So now you've got this little flange that's ready to support the lid across that area. Heck yeah, there's a new flange there. Okay, now we got to do a little bit more major work on the other end. It's a little bit difficult here. It just took me a little trial and error. So what I've done here now, and let's see, how can I kind of want to recreate this and kind of help you along here maybe. So I might just let me think here. I'm just going to start a new part and real quick, just so I can kind of be where you would be to do this. Um, so bear with me for just a second. I'm just going to derive in that base solid that I'm using here as a surface. I'm going to do a quick little thicken. I guess just got to set my sheet metal. Just bear with me just a minute here. I'm just going to modify. I'm not going to save this part, so I'm just going to do a quick, but I'll make it look like it is. I'm just going to mess up my default one a little bit, and let me make sure that I set that 2 to be 0.3, 0.03. That makes a difference. And I'll even set this here in case it's not going to impact anything. Yeah, okay. And then I'm just going to quickly thicken these ones here. This was a part that you guys have. Thickness. Okay. And then we used thicken again on these 3 parts as a separate solid, right? That one, and this one is the original way we made that as a new solid. So you have that like that. Then we came in here and we did some bends on it. I think I used the bend command on sheet metal and we chose this. And then we chose this side. Whether we did the cutter bend first, I think we played with that. And it didn't really make a huge difference on how it looked. But then and then we came in here and I did a cut. So I'm gonna do that real quick. Turn off my surfaces real quick. And I'm gonna do a quick sketch here. This is where I kind of drew my cut sketch anyway. It was on this was on the plane of the part actually. And then all we did was I think the geometry we projected was the outer that one like that. And then you're gonna have to probably modify this cut anyway. I'm gonna show you how I'm gonna cut it real quick. I'm actually gonna draw this in rather than I projected my so we may have to redraw that a little bit. Let me see. Because I think you guys will have to maybe remake your cut. And you're gonna remake it about like I'm making it here. But let's just wait. Oh, what did I do here? Oh, I did some, oh, see, I did that funky loop on the end of that when I pulled away. Sorry. I'm making this look harder than it is, but let's see. Aha, that's constrained. And so I'm just quickly checking, or I'm quickly doing just a cut there, thickness. Yes, okay. So we kind of have something similar to this, only yours, hey, this one actually worked better. Oh, even mine now has like the bend radius not getting cut by my cut command. So this is also weird. in mine. I think R is actually, and it's just because it's an order of operations thing here. It just kind of ends up looking different now um, than maybe you guys have, because I think we had this gap over here, right? It kind of terminated the bend and then left a pretty big gap here. And this one looked better. I was happy with how it looked over on this side. So what I want to do is I want to show you what I played around with. There's multiple ways to do a bend. And so you would have something similar to what I have going on here now. And what I want to do is I want to play with this thicken uh, the thicken command that we use when we created this discharge chute, which is this one thicken command. I think we thickened all three surfaces at the same command. I'm going to change that up. So I'm going to come over here and this is going to blow up my bends and it's going to blow up my cuts. And so I might just bring my end of part up above and so whatever model you have, whatever information, grab the end of folded and bring it up to where that thicken command is like this. And to where you get back to the original way we thickened this part. And let's modify this at this point. And so what I chose to do was go back into this command. Remember, I don't really want to delete it and start it fresh because it is driving a part underneath me. Like we've already created the part from it. So if you start deleting this stuff, it's like that part disappears and you'd have to it's not the end of the world if you do that. You can always resend it to the assembly. But here, if I can prevent that, maybe it's easier. And there's parts of this that I want to keep. I just want to not do them all as the same thicken command. So what I'm gonna do here is I'm gonna go in here and edit this feature. And I'm gonna instead of choosing all three faces as part of this one command, I'm gonna X this off. I'm gonna reselect the faces that I want, and I'm just going to select this side first. And it should be, it's already set to create the new solid. It's going to be just a thickness distance that we are extruding it. And then I'm just going to say okay on that. That's all I'm going to do for that first thicken is that. I got to turn back on my surfaces maybe. I am on the I would be on this not the assembly file they created, but my what I call is my part assembly file. So it's the one that I exported my made components from, but it's not the one that was created after I made components. That's this one. So any changes, and this is why I'm doing this, is just to, the more we do this, the more you get your head wrapped around what's going on in this order of operations thing and the way that one part file affects the other. So I'm back to this one because this is where I exported those parts from, and any changes I make to this will automatically update on the assembly file that I created from it and the parts. So it's just going to be that you got to go back to the drawing board here a little bit and say, oh, I'm going to go back to here and make some modifications, and those will feed it the assemblies and parts downstream from it. So yeah, this is I don't know where the book is you learn this stuff, but eventually you learn this with some experience. In how to make parts, what we're trying to do is just make things adapt themselves, right? Like to do minimal work and let that change affect your parts downstream rather than going into each individual part. So, and having to make changes. I'm going to try to drive changes uh, like this from this controlling part here. So yeah, I'm back to this one. The way I identify that this one is different than this one is I've kept like this one. I mean, it looks different on the model browser. It looks like individual parts. So that once I open it, I can definitely tell what it is with some experience, obviously. This one obviously looks different. It looks like everything's been created here and it has my surfaces showing. So it's just the way I'm visually keeping the difference between the assembly that's going to end up on my drawings and what's driving those changes here. This won't end up on a drawing, by the way. This is just to drive changes. It's kind of like to go back to the point where they were all created from. Okay, so I'm back into this one. So yeah, this is the one I'm messing with. Was the original first part we created and we derived in the solid. And that's kind of what I've recreated here to just kind of show you what I'm doing. So and then I've gone back and I've located the original command that I thickened this discharge chute from, and I've actually stripped away all the faces and only made one face thickened. But it still maintains that that's a thickened command. And then, so if I was to go to my other assembly now here, it would drive the changes on that part and it would just become a one-sided discharge. and because it would be being fed from here. But what I want to do though is now I'm going to say I'm going to thicken the next as a different solid itself. So this is just another way to approach kind of this. It's like I didn't love how that way was coming out. So can I come up with another method to kind of do the same thing and get to the same results, but maybe get better bends where those two meet? So that's my process here. So I'm going to say, well, let me try this. I'm just going to thicken one side, and then I'm going to come in here and I'm going to thicken the other side independently. So this is this side now being thickened independently. And I'm even going to change it to a new solid. That'll even drive its like that it's independent. If I thicken it and have it as a join solid, it's probably it's going to want to know what solid to join it in, and it's going to become about like what I already had. So I'm trying to kind of drive a little bit of a separation here at first. And so I'm going to say new solid here, and I'm going to say okay. And what it does is it definitely makes a different joint. It makes like an outside corner joint to what's going on here. And so, and they are independent solids. I would be picking up a new solid on my list here, and they are independent at this point. I'm going to do that one more time to the third side. So I'm going to come over here and thicken this one independently and make it a new solid and say okay. And so now I've got this as a three-sided, three-part discharge chute. But now I'm going to go ahead and say, well, I actually want these to come together. And so I'm going to bend those now. And so if I go back to that bend command, it's just a little bit of a different bend now because it's not like a joined part. They're independent parts. But when you bend them together, it will understand that we're joining these together. And so I'm going to say it recognizes this is a double bend, a double edge bend. So it needs two edges to make this bend like this now. And essentially, it looks like back to what we were doing with the original part. I'm going to say okay on this. I'm just two edge selections and okay. And what it does is it kind of like this shows that this was a thicken command, but now it's kind of like it's inactive. It's because it's been consumed, and the program's smart enough to know I've just joined two solids. Now, and if I'm bending those, they're going to be one piece. And so it is still an important step that it was here, but it's kind of been overridden by my bend command now. And I'm going to do that again over here on this bend, just adding a bend, but it's a two-sided bend here. And I'm going to say okay. And now I've got those two thickens that have been absorbed by these bends into this one. They are now considered the same part. And then I'm going to do my cut. I already really have my cut, so I might just, and you guys probably have a cut somewhere down on your list. And these other bends, they're not going to be useful anymore. So now that I'm going to move my end of folded part down below my cut, wherever I did the cut through that part, which yours might have some other steps in between than mine does here. But what I do is I take that and I'm going to just pull it down. You might get an error because it says, hey, you've got these other bends where you have bends. You just accept that and let them blow up. And really what I need to do is get rid of those old bends. So I'm just gonna shift select them and delete them because I don't need those ones anymore. I'm not gonna maybe this is where I'm generally untoggle this when I'm deleting features, but maybe there's a sketch that's dependent on them. Sometimes I don't want to delete that sketch, so I'm gonna say maybe don't delete that and say okay.
So instead of making it this thicken, you made it a new solid.
I did. I did still use thicken. I used that command, but then I just created new solids for all three sides. And then I use my bend command and because it's a different looking solid, I mean it's a different looking corner joint, and it causes me to have to pick two edges. The command does because what I've created is an outside corner joint of these parts. And so the bend command is a little bit different now because it gives me two edge selection options. Um, yeah. Oh yeah, I just deleted them. And in fact, you might want to delete your cut too, actually, because the cut will be easy to recreate. Because my cut is still kind of dependent. Let me undo it. Oh, sorry, I don't want to save it. Cancel real quick. I just want to undo. Yeah, when I moved my end of folded down below my old bends and my old cut, I just selected them and deleted them. In fact, I think it probably would benefit you to delete your cut. Otherwise, it's going to kind of keep some of the parameters So I think I'm gonna redo the cut. Redo the cut. Yeah. So I'm gonna get rid of these bends. If you just get rid of the bends, I just select them and say delete. Maybe I'll keep this checked on. Go ahead and delete that cut sketch. Instead of unchecking it, I'm going to leave it checked and I'm going to say okay. And it should actually got rid of my cut for me too, because the cut was dependent on that sketch. The bends were kind of somehow they were kind of involved in that whole cut. Like there was a relationship there. I've just kind of deleted those out. So now I'm kind of back to square one in some ways. I did new bends. Yep, yep. I did new once I thickened those sides, I made new bends, and that's what I've got there. Now I got to make a new sketch to cut that back out. So let me do that. For me, I got to turn off my surfaces, turn the visibility off. And this is where and so I'm actually choosing that original cut sketch I think we drew here as well. I'm going right back to that and saying, let's use that surface as my sketch surface. F7 slice to graphics. And this is how I chose to do this new cut. I projected my outside housing right here. I want that U shape like that, right? So I've projected that. That's what I want to cut through and allow that one to pass through this other one. And then I just chose to draw a line rather than like I didn't have like because it has a bend in it, it has some like weird geometry here. I'm just going to draw a new line from this endpoint all the way across here. And then it's constrained. So it's really no dimensionally constrained. It's just a projection. I don't think I need this one. And sometimes you'll have other projections show up. That one was, for whatever reason, I got tied into. No, it's all good. Yeah, sometimes when you're drawing on that, it'll choose to project some stuff if it feels like you locked in on a point from that geometry. I try to be careful with that. I only try to project stuff that I want. And so this is how I've drawn my instead of having to come in here and project this little piece in order to connect that, I was just like, I'll just draw a line across. Just as a note here for those that understand what I'm going here. Sometimes when you're doing this and I'm using this just to get rid of this material. There are times when sometimes I'll actually maybe go up like 30 thousandths or go up even 20 thousandths or 10 thousandths above how much I want to cut so that I can ensure that I like remove the entire material that I'm looking to cut. So just be aware that sometimes especially in some sketch positions, you might have to kind of overextend the profile that you want to cut kind of beyond the point of the material. And so every once in a while, when you do cuts across bends like this, you can kind of get some fragments of the part still remaining, and that can sometimes throw off a flat pattern, not let it flatten out. So I don't think I had that issue here. I think I was able to just project that single semicircle and then connect the tops. And that's going to be sufficient to remove the material here. But just watch yourself every once in a while. Sometimes you have to offset that a little bit more to make sure you cut it through clean. And then I'm going to say finish that sketch. I just need to reperform that cut. And it's not right or wrong to go either way. A 3D model extrude cut or a sheet metal cut here is what I'm going to use. Just because it's preloaded to do thickness. And it already preloads, it actually selects the solid that I want for me. If it didn't, I just need to make sure I select the solid that I'm going to cut. My profile has been chosen because it recognizes that it won't even let you cut if the profile is not closed. So if you're not getting the cut function to even recognize a profile, then you got to go and troubleshoot, look for a closed loop on a sketch. So mine is good. Normally in here, I would do this cut across bends. This is one that this isn't working for me here though, actually. This cut across bends, I haven't, I was troubleshooting it a little bit yesterday. I'm just like, I don't know, because this is a perfect scenario where I'd want to cut across bends. And it could be that I need a little more than just the thickness in order to do that. I don't know. Normally I can use this command. I think I'd have to do a little more homework and see like what do I got to set in my sheet metal defaults to get that to cut across my bend. So I just chose to keep this, which is to define the profile, define how much you want to cut, define the direction, and define which solid it's cutting. And then I just said okay on this. And I do believe I have some remnant of the bend still left. But I definitely what I ended up with was it was something that I felt like I could work with better on the individual part that looked better in this model like this. So it was actually filling in that mainly it's filling in this hole on this side that I didn't love. Yours won't do it. Yours has a bunch of bend here. Like it looks like it before. Oh, well, that sucks. When they're, yeah, but you still have a bunch of fillet there. Oh, yeah. So mine, um, that could be true. Like, it's funny you mentioned that. I could bring my sketch face back to, because I have drawn my sketch on this inside face. Maybe it would be better to draw the sketch on this face and to let it be cutting through that way instead of because it really I'm cutting I guess in some ways I'm cutting from this face that way and so that's what's leaving this here, right? So let me show you this. This is also good to know, and I've shown a few people this individually. You can redefine a sketch face or where a sketch like lived. You can redefine which plane that was on without having to just redraw or delete it and redo it. So if I have this sketch and that's so I'm going to play around with this a little bit here, see if I can help some of you out. But there was my sketch plane was the inside surface. Maybe I want to cut the other way. Or I don't know, maybe I want to redefine this. And so what you do is or just as if you would right click your sketch and go into edit it, there's actually a redefine on this menu here. And that that's going to allow you to pick like a new face that this sketch lives on. So if I select redefine, it kind of highlights my sketch and it kind of shows me where that sketch lives. And I don't think it's going to change much though, huh? Because well, maybe it is. Yeah, I think it's drawn on the inside. I'm going to say, how about this outside face? It may blow up because it's got maybe the cut feature has got to be changed here because I'm coming from the different direction. So the cut has blown up on me, but really now my sketch lives on the outside surface. So that is really handy to redefine a sketch like where it lives. When you and the other thing is it kind of reminds me of this is when you're establishing like new working planes um, you can redefine, you can select those working planes. Like if I had a model that had a bunch of different working planes that I've established and I don't like the position of them, if you right click on those working planes in your model browser, there'll be like a redefine for those as well. So you can move sketch planes around, which would move the sketches on them. So there's a lot of this that goes on. I don't always pick the right way always. So it's nice that Inventor will allow you to move those pretty easily.
Where people can exactly the
Well, then that's what I'm going to look at here because I've moved it. Now what I'm going to try to do is like cut beyond just a thickness. So I'm going to come in here and re-edit my feature. I think for one, I've got to go the other direction now.
same.
And then and then can I cut across bends here? Still not. I was hoping I could cut across bends there. And if you do a thickness times two, I don't know if it'll accept this. That definitely cuts through. Like visually, it looks like, so all I've done is extend beyond. I and it's almost like going to cut this through that bend a little further. Let's see how this visually looks. If I just oh, so we don't want to go that far. Yeah, maybe we just want to go a little. Yeah, because I mean that did cut a big hole, left a big thickness hole essentially there. So maybe I'll just do like 30 thousandths more than the yeah. This is kind of what I play with a little bit here. How deep do I cut that? Two times the metal thickness is just a little bit one thickness isn't enough, but if I add like 30 thousandths of cut here, not an equals button here. Actually, that would drive something different. I want a plus. No, nah, this is good. This is good. Oh, you mean like a bend on the circular corner? That would be impossible, actually. So you'd be trying to get it to do an impossible. Not that inventor wouldn't try to do it, but actually folding an edge on a circular thing would be inappropriate use of sheet metal. Yeah. That's a good point though, Ari. Like I like the way of thinking. It's just that understanding the tools and how things bend, it will come to you in like you're not getting what I'm getting here.
Error.
On the cut. I've done my bends first and now I'm doing my cut. The cut default should be just thickness. Mine is allowing mine to cut. Yours is not though. Does it look worse than before? So are you on this like are you choosing have you messed around between these two here? This was trying to cut across bends, which def and then over here you still can't. Well, this is what I'm doing it on, actually. Yeah, yeah. It's just yeah, it's like a test. I did test that the first time we did this, and I didn't get it. I didn't get it. Yeah. But this I was kind of happier with. Whether you do like a little bit more or less to cut that out, I'm gonna leave mine just with thickness cut with a little bit of the bend remnant here. I'm gonna go look at the part at an individual and see how the flat pattern looks on it now. I did plus 30 thousandths. Whether that was good or bad, I kind of went back to not the 30 thousandths. But
Dylan's batting.
maybe I can come around and take a look. It looks different than mine, though, is what you're saying. It does. Like I definitely still have a ridge of the bend inside my, but it's not like the whole ridge. Yeah. Oh yeah. Okay. So let me come take a look. Let me just hit my pause button real quick. Now's a good place to take a break anyway. I'll just end this recording.